In this video, we are going to perform an independent samples t-test, or a t-test for two independent samples, which is used to compare means of a numerical outcome variable among two groups of a categorical independent variable. Here is the data set that we are going to use for demonstration. You can access it through a link in the description of this video. In this data set, we have got an outcome variable called test score, or the performance of students, and then we have the gender of the students. A t-test is suitable for analyzing this data because we have a numerical outcome and then a categorical independent variable with only two levels. We are going to compare the mean performance of males to the mean performance of females. We want to see, is there a statistically significant difference in performance of males and females? So to run an independent samples t-test, simply click on statistics, go to summaries, tables and tests, then you go to classical tests of hypothesis. Then we shall select the t-test, the mean comparison test here. In this dialog box, we are going to select the type of t-test that we want, and we want the two sample using groups. That's the independent samples t-test. Then click on it and we specify what is the variable name, the outcome numerical variable, which is test score, and what is that grouping variable. In this case, it is gender, because we are going to compare males and females. That's the grouping variable, and click OK. So in this output, we have the command that you would use if you didn't use the menu, and then we have the descriptives. We have for our group, we have a total of 44 males and 56 females. The average test score among males is this, and for females is given here alongside their standard error, standard deviation, and the 95% confidence intervals of the mean. We also have the combined statistics, a total of 100 participants, overall mean, and the other statistics. Then we have a difference in the mean of the two groups that we are comparing. And this is the difference we want to find out whether it is statistically significant, whether one group performed better than the other. And it is a negative 5.4. Here we are interested in the magnitude of the difference, not the sign, because this would depend on what have you put first. Below this table, we also have the null hypothesis, which states that the difference between the test score of the two groups that you're comparing is equal to 0. In other words, they are the same. There is no difference. We have the t-value and the degrees of freedom, which is now 98, n-2. For our interpretation, we have got three alternative hypotheses that can be tested against this null hypothesis. Usually, we test the two-tailed hypothesis. If we say the difference is 0, the difference may not be equal to 0. Either males are higher than females or the other way around. That is the two-tailed hypothesis, which we interpret here, saying the difference is not equal to 0. And when we look at the p-value, it is less than 0.05, the usual alpha value, indicating that there exists statistically significant differences between the test scores of males and females. If we wanted to interpret the one-tailed hypothesis, that maybe the difference is less than 0 or the difference is above 0, that is the p-value, we would do interpret. For you to report results of this analysis, you can first look at the actual mean values. You can see that females have higher scores than the males, and that is statistically significant. So we can say females had significantly higher test scores than males. Then you quote the t value here, and it is p values. If you found this video useful, consider liking, subscribing, and commenting to the video so that you don't miss out any of our next episodes. Next, we shall look at the paired t-test, which is used to analyze a pair of related data. See you in the next episode.